I'm sorry that I have to record today, but my son is sick. So we're going to talk about vertex form and intercept form today in class. So vertex form is awesome. It already gives you the vertex. You don't have to show very much. It really is the best form there is for quadratics. Intercept form is also very handy if you need to have the zeros. So we're going to go over what each of those look like. So last class we did standard form, which we see quite often. Ax squared plus bx plus c. But we have these two other forms that are very handy. Y equals ax minus h squared plus k. This is called our vertex form. Now, why it's called vertex form is because right in the equation we have our vertex. H and k always represent the vertex. H, k. Now remember, when we did absolute values, it should look extremely similar. We had x minus h, absolute value, plus k. It basically does the exact same things that we did before, except now we have a parabola shape instead of an absolute value shape. It's very simple. So we're going to follow these steps in order to find our vertex form. We're going to draw in the axis of symmetry, which we'll find in a second. We're going to plot the vertex. We're going to evaluate the function for two values of x, or we're going to cheat and just use the a value as we did earlier. And we're going to reflect those points and then make it with a smooth curve that looks like either a smiley face or a frowny face. Hold that water or drop that water under. So in this case, our axis of symmetry is very easy. We do not have to remember any formula for it. It's just x equals the h value. Now remember, our x's lie to us. So if it says that it's a negative, so if it has in here x minus, let's say 2 squared, it's not a negative 2, it's actually a positive 2. It goes the opposite direction. Our vertex is hk. So again, opposite the value, because we switch our sign. K, it doesn't lie to us, it stays the same. Same idea is if a is greater than 0, it opens up. If a is less than 0, it opens down. If we have a value that's less than 1, it is wide. If we have a value that's bigger than 1, it is narrow. So the closer to 1 you have, the wider value you get, and less than, if it's bigger than 1, like 2 or 3 or 4, it starts getting narrow. It has that steeper slope. The one that's less than 1 has that wider slope that we think of. It's not really technically slope. So we'll get to that in a second on how we're going to graph this. Intercept form is very, very handy as well. So what I mean by intercept form, it's where the graph intercepts the x and y axis. So we're going to give these values a p and a q. So p and q are where we're intercepting the x-axis. Sometimes it's very useful to know, and it's kind of handy to find. So in this one, we're going to easily plot the x-intercepts. Notice x is lying to you again, right? See that x minus p, x minus q? So if it says x minus 2, x plus 3, we know we're using the points 2 and negative 3 as our x-intercepts. So we'd go over here at negative 3 and at 2 as our values. We're not using the other ones. We're not using the exact thing that we see, minus 2 and plus 3. It's because our x's are lying to us. That negative built into there flips our sign. We're going to plot the vertex. I'll show you how to find that in a second. Plot the y-intercept. Now the y-intercept is a little tricky to find, but not too bad. All that you have to do is multiply the constants. All right, so it's going to be a times negative p times negative q, and that's going to get you your y-intercept, because our y-intercept is the constants. It's when there's no x going on, because x is 0, so we just have to worry about the constants. Reflect the y-intercept across the x-axis. Again, if that y-intercept is too big, we're not going to worry too much about it. Sorry, I said x-intercept. I meant axis of symmetry. All right, so again, x-intercepts. These are going to be the p and the q. Remember that x lies. Now our vertex is a little interesting. Our vertex is always going to be in the middle of our p and our q. So how we're going to find that is we're going to take, I'm going to move it over here because there's not enough room. We're going to take our p and our q and add it together and divide it by 2, because it's the average between our 2 points. So if we were to find the middle of our 2 and our negative 3, we would add 2 plus negative 3. Oh, sorry. Yeah, that's right. Oh, my bad. Back up. 2 and negative 3, divide by 2. That gets me negative 1 over 2, or negative 1 over 2, negative 1/2. If you see that, that's kind of right in the middle. So I should have drawn this a little better. Should have gone right about there. So again, all that you do is you take your P and your Q, add them together, divide by 2. That gets you your vertex. That gets you actually just the X value of your vertex. How do I find the Y value? Well, I plug it in to find the Y. All right, Y-intercept, you take your A times your negative P times your negative Q. You just take the constants and multiply them together. A times negative P times negative Q, that gets you the Y value. Same rules apply for the A. No big change. You just move over 1, and then you go up or down depending what A says. So the first thing that you're required to know how to do in this section is, if you always want to revert back to standard form and do it that way, then you could do that. But you're just going to have to do some multiplications with it. So we're going to write each in standard form. If you want to try this out before you go ahead and before you see me do it, go right ahead. If you want to just go with me, go along with me. Otherwise, pause the video. All right, so if you pause the video, great. If you did not, that's fine. I'm going to multiply these out. So I get x squared minus 4x plus 6x minus 24. That gets me 3 times x squared plus 2x minus 24. Then I multiply the 3 throughout it, so I get 3x squared plus 6x minus 24 times 3 is 72. And that would be my final answer. And then you could use that to graph it if you desire. The next one, I would have negative 1/2 times x squared plus 16x plus 64 plus 35 on the outside. That's what x plus 8 squared is. I'm going to distribute that negative 1/2, and so I get negative 1/2 x squared minus 8x minus 32 plus 35. Combine my final like terms, and I get 1/2 x squared minus 8x plus 3. And there's my final answer. All right, now what we're going to do is we're going to graph each of these. And again, when you have that vertex form and that intercept form, it's just as easy to graph if you know what you're looking for. So in this case, I'm going to start off looking for my axis of symmetry. And my axis of symmetry is always x equals my h value. And in this case, my h value is 3. Remember, x lies to you. So I'm going to quickly go over here, and I am going to graph my axis of symmetry. Then I need my vertex. Well, in this case, again, my vertex is really easy. It is given to me, 3, negative 5. Don't have to plug anything in. And I'm just going to go down here to negative 5. 1, 2, 3, 4, 5. I believe it's right there. Yeah. And I am going to graph that point. I'm going to change colors just so it's easier to see. And then from here, I need to graph another point. Well, I'm going to use my a value. My a value says I'm going positive. So it's going to be 1/2, so it's going to be wider. So I'm going to go over 1. So you always go over 1 no matter what it says. So a is 1/2. You go over 1, and over mean left or right, doesn't matter. And in this case, we're going to do whatever a says. And in this case, a says go up 1/2. So I'm going to go over 1, up 1/2. I'm going to reflect that over on the other side. And I have another point. And then, because I'm lazy, all I'm going to do is going to graph it. And then I'm done. Now, on the other end, I have B. B is kind of hidden, but this one is not in vertex form because of not having an x squared here. So since it's not in vertex form and we're practicing the other forms, we know that it's actually an intercept form. So since it's an intercept form, we need to know what our P's and our Q's is. So what it's actually saying here, if I rewrite it, it's saying negative 1 times x minus 0 times x minus 4. So in this case, my P is 0 and my Q is positive 4. These are my x-intercepts. And it also tells me my A is negative 1. What it's not telling me right now is what my vertex is, and I do need to find that out. So if I quickly, though, graph these values for my P's and my Q's. I have a P right here at 0 and a Q at 4. 1, 2, 3, 4. And now I need to find my vertex. Now, since I know A is -1, I know my graph opens down. So that means that I kind of know, I'm going to erase this in a second, that my graph should have a vertex somewhere up there in order to make sure that I'm doing this right. Okay, so but let's find our vertex point. What I'm going to do is I need to follow my formula, P plus Q over 2. So I'm going to do 0 plus 4 over 2, which is equal to 2. So my vertex has a coordinate point of 2 something. And now I plug in my 2 into my original formula. So I have -2, and then I go 2 minus 4. Well, this gets me -2 times -2, which gets me +4. And look, I am in the area where I thought I would be. +2, 1, 2, 3, 4, right there. And then I can follow a little bit of my A. My A is saying to go over 1, down 1, and it gives us a nice little point there. And since I already have my y-intercept, I don't have to find that either to help me out and get me another point. And I'm done. My axis of symmetry is right there at 2. X equals 2. I didn't write that over here. My axis of symmetry is x equals 3 on the other side. But on this one, my axis of symmetry is x equals 2, and I can see that I am symmetric across that line. And notice something that on each of these, this one, I have a +1, so I have a minimum. On this one, I have a negative A, so I have a max. All right, now if you want to try out C, go for it. If you don't want to try out C, don't pause the video, but I suggest pausing the video now. All right, so if you've already paused it, great, and done it, perfect. What you would have found was you had a P at 5 and a Q at -3. 1, 2, 3, 4, 5. 1, 2, 3. And from there, you should have also done 5 plus -3 over 2. That gets you 2 over 2, which is 1. That is the first value of your vertex, 1 something. I'm going to plug 1 in. I get 4 times 1 minus 5 times 1 plus 3. That gets me 4 times -4 times 4. Ew. Not that nice of numbers, huh? Did I mess something up? Let's see. 5, -3. Add those together. I do get 2. Divided by 2 is 1. It should be about there. That makes sense. And I plug 1 in. I get -4. And I get 4. Yep, that's it. So 4 times 4 times 4 is 64. Ew. Not very pretty of a graph. All right, well, if you got that, that is the right answer. And so 64 is all the way up there. So I guess we got to change our graph around. So 2, let's bump it up by 10s. 10, 20, 30, 40, 50, 60. I am totally faking it right now on where this graph should be, and then we'll go down. This is a very ugly situation. And let's double check something. Nope, that should be right. Oh, no, it's totally not right. Sorry. It's not positive 64. It's negative 64. Right? We should be going up, not down. So we're over here at -3 and at 5. 1, 2, 3, 4, 5. We plug our 1 in, and we should be down here at -64. Still not very pretty. 1, 2, 3, 4, 5, 6. And then we're going up. But that would be our answer. And yes, we totally modified that graph to make it work for us. But, you know, sometimes you just got to do what you got to do. I know some of you are going to be laughing at me right now. That's okay. All right, now our next one. Example 3. Although a football field appears to be flat, its surface is actually shaped like a parabola so that rain will run off both sides of it. Kind of interesting, though. The cross-section of a field with synthetic turf can be modeled by this function. This is in what form? Yes, if you answered Intercept form. You're correct. So we're in intercept form, where x and y are measured in feet. What is the field's width? All right, so the field's width. Okay, so here's our field. It is so slightly curved. We want to know how far it is from here to here. Well, hopefully those are our x-intercepts. Now, those aren't technically our intercepts. They're a little different, but typically this is what we're talking about. We're wondering how far the distance from here to here is. Okay, so let's find it. Okay, so again, I'm going to rewrite this so it looks more like my x-intercept form. So negative 0.000234 times x minus 0 times x minus 160. So I have one intercept at 0 and my other intercept at 160. Oops, as I write 130. At 160. Okay, so where then would our intercept be? Or sorry, how far? Our intercepts are at 0 and 160, so how far is our field apart? Well, it looks like it's 160. Let's see, what units are we using? Feet. So 160 feet apart, because one is here at 0, and then the other one's all the way over here at 160, and it's curving so very slightly. So it's 160 feet apart. What is the maximum height of the field turf? Well, that's asking for the vertex. Now, which part of the vertex is it asking for? Well, it's asking for the height. So not how far it is from the width, it's asking for the height. So it's not asking for the x, it wants to know the y value of our vertex. So specifically, it's asking for the y value. Okay, well, we find our vertex by going and taking 160 plus 0 divided by 2. That gets us the x value. So 160 divided by 2 is 80. And then what I need to do is I need to plug in 80 into my equation of 0.000234 times 80 times 80 minus 160. So let's see what we get for that. 0, so I'm pulling out my handy dandy calculator because I can't do this one on my head. And I get 1.4976. And so that means that we are 1.5 approximately 1.5 feet above. And that's it.